Good morning, everyone. My name is Alireza Jazairi. I work at Development Seed. I'm an engineer there. And Development Seed, we actually have this conversation from time to time that when someone asks us what is Development Seed, how do you answer that? We have this kind of one-liner that if you go to our website, you see that often. Is called Open Tools for Open Data. I kind of like that as a very short explanation of what is Development Seed. Today I'm mainly going to talk about the work that we have done on Landsat imagery and the open tools that we have built and the kind of work that we are doing on Landsat imagery. To begin with that, I guess as we all know, the Earth observation is going through a revolution. There are just so many sources of data and information that you can access. There is really more public data on satellite imagery than ever before. Just NASA, I kind of did a count yesterday. If I'm not wrong, there is at least 21 satellites that are already over the sky that are just owned by NASA. Many of them are providing open data. European Union, for example, has over 8 satellites right now over the sky that provide open data. The NASA examples, I mean, of course, Landsat 7 and 8, Aqua, and others that you're all familiar with. European Union has Sentinel-1, Sentinel-2, Cryosat, which was another name, and a bunch of others that provide very valuable satellite data. But I guess the biggest problem is that how you access a lot of these data. Not every one of them is public. Not every one of them is actually easily accessible. And those that are really kind of designed and geared for very specific audience. I think, at least speaking of, for example, the Landsat data, until very recently, you can easily argue that this data is really, the way that the data is delivered is really designed for people who are very familiar with the data. Whether you are a remote sensing scientist or a person who has a very good idea of what Landsat data is, what the sensors are, how you can access it, how you can get it, how you can download it, how you can process it. And to give you some context of, for example, how you, at least until very recently, how you used to access Landsat data, you would go to the Earth Explorer website that I think a lot of you have been there. It has an interface that, in my opinion, is not really the best interface that you can deal with. It has a lot of options. It do a lot of things. You can search with so many different variables through so many different tabs, and you really have to spend some time to get used to it and figure out how to work with it. Most of the time when you deal with Landsat imagery, you need more than one image, which means that after you kind of search and figure out what images you find and figure out how to kind of order these images, then you have to go and download another tool called Bulk Downloader. That's the Mac version of it over there. And then you have to create an account, you have to log in, you have to wait for a while, depending on how many images you have asked for the images to become available. Then you start the download process, which is not really the fastest thing. You spend more time downloading the images, you end up with a bunch of zip files. Each one of them is about 1 gigabyte, a little less. Then you go through the process of unzipping them, so you can actually have images that you can use. And that actually sometimes takes more time than downloading the images. It's a very cumbersome process. And you end up with a bunch of dark images of different bands. If you're familiar with these images, that's actually what you expect, and it's not anything surprising. If you're coming from a different discipline, if you're not familiar with these images, but you have a use case for them, it's kind of very scary when you look at those images and try to figure out what to do with them. Again, if you're not from a remote sensing background, you probably go around the internet, do a lot of search. If you're on Mac, you end up with a bunch of open source tools such as GDAL and other things, and then you work with a command line, write a bunch of bash script, and then run it. You probably see a lot of errors. You go back, you read forums, you do a lot of things to reach to this image if you want to have like a colorful version of what you were trying to do. And if you have downloaded multiple images, you have to go through this process for every one of them. Which I think is not a problem if this is what you do. You easily find ways to do it faster and better. But when we were dealing with this last year at development stage, we were thinking that this data is really valuable to other groups of people, to non-scientists, but also we were saying that this is actually very useful for computers too. I mean, you need a computer, you need computer power to analyze this data, to do other things with it. And so our goal was to kind of make this more accessible to both groups, both people who are not familiar with this data sets intimately, and also to our computer program, so we can do more stuff with it. And through our work, we created 3 tools. One of them is called Landsat Util, another one is Landsat API, another one is Libra. All of them are open source. We are very committed to open source, and whatever we do is really out in the public. Other people can use, can contribute. And these tools were really designed to answer, our challenge here, which was how you make it more accessible to people. How to make it more accessible for a journalist or for an archaeologist or a person who do agriculture, or people who might have actual use cases and they are also interested to access the original data to do more stuff with it. I'm going to very quickly go over these 3 tools and give you an introduction. That's how they make a difference, and then from there I'm talking about the other things that we do with Landsat Data. So Landsat API is a very simple tool. I mean, all it does is it allows you to search Landsat metadata a lot better and easier and faster. We made this by having access to the Landsat metadata in a raw format, in CSV format. And it's just possible because USG put the Landsat metadata in CSV format every day on their website. If they hadn't done that, it was impossible. Big shout out to them. It's a simple API. It turned that data into kind of a RESTful API, so it has a web URL, and you can browse through the data, you can search the data by any of the parameters that exist in the metadata, from like its latitude and longitude to its name, its date, location, rows, paths, all the other things that are related to Landsat metadata. On top of that, because we had created this RESTful API, we were able to put a web interface on top of it, a graphical interface, so you can actually see the data if you're not interested to work with the API, or if you're not a machine to kind of interact with the API. And this tool is a very simple browser that just allows you to go through all of the Landsat imagery, apply some very basic filters, see the preview, and download the image. It brings down the amount of time that you would originally spend on Earth Explorer. It significantly reduces the amount of time that you need to kind of find an image and actually see what images are out there that might be helpful to you, something that is very difficult if you want to do on Earth Explorer. And then we also built a command line tool, which its purpose was really to kind of give you the ability to download images in bulk, like as many images as you want, and also do some basic processing on them. For example, turn them into a true color image or an NDVI image, or, the different band combinations depending on what you want. The command that I have up there, that little red line, that's equivalent of, I'm going to go back here very quickly, to these 2 slides, this one and this one. That little command that I have over there essentially does that. in this example, although I have already downloaded the file, so it's a bit of cheating, but that's like 31 seconds of image processing, which I bet if you wanted to do the same thing on Earth Explorer and go through that process, it would have definitely taken more time. The point here is that all of these are open source tools, very simple tools. I mean, they're not as complicated, but our goal was to make this process easier and faster for a broader audience. And what we didn't expect was the kind of reception that we had. We received a lot of positive comments, a lot of people who started using these tools and build other tools with them. And so the tools that I just presented and a bunch of others have really become the building blocks of other tools, of other cool technologies. I'm just going to show you 3 examples of them. I'm going to start from the bottom. Landsat Bot is a Twitter account that just posts a random Landsat image. I'm not sure the exact frequency, but it posts a few images every day. It uses Landsat util. It has made an automated process. And in other words, our Landsat util has become kind of a computer tool that just goes, get images, randomly process them, and post them on this Twitter account. A very, very interesting use case for our tool. Snapsat is another one. Jed mentioned it yesterday. This is apparently a student project. What it does is allow you to easily process Landsat images and actually compare them and do different processing with them. For example, you can get 2 images from 2 different dates, and it allows you to put them together and kind of have a slider and go back and forth and see how the image has changed. And it uses Landsat util, and I think it also uses Landsat API to get the right metadata for the images. And then another project that uses our tools extensively, and we are also involved in that project building it, is AstroDigital. This is an Earth monitoring platform. It's a startup that has just started, and part of its infrastructure relies heavily on our open tools, and AstroDigital is actually contributing to the open tools that we have, and they're committed to make sure that whatever we develop is accessible to all the other developers and people who might reuse them. In the AstroDigital case, what they needed, and what we are working on with them, they needed kind of an on-demand, scalable satellite image processing platform. And what I mean by on-demand and scalable, especially because this is a startup. I mean, we are not talking about a huge company that has unlimited resources and can run multiple machines at whatever scale. They wanted a system that if you have one image, you can easily process that with whatever processing pipeline that you have. If you have 10,000 images at the same time, you can still do that, and you only pay for what you're doing in a way that is easily scalable and can move rapidly from one image processing to tens of thousands of image processing, depending on the demand and depending on the resources that this startup has. The way we approached it was we essentially kind of find ways to make our tools scalable. So one of them was we tried to make our Landsat API scalable. This part of it is actually relatively common. I mean, it's a web application. I mean, it's a web API, and so this is essentially what you see with a lot of other web applications. We try to do this as cost effectively as possible and at the same time as performant as possible. The data stores that we use for our Landsat API is MongoDB and Elasticsearch. Both of them are schema-less databases, very powerful. The different thing that we did, which is new for us, and I don't think a lot of other organizations are also going this path, was really using Docker as the building block of the whole web application. So all of these services are run in their Docker containers. And then we use this new Amazon service, which I think is less than a year old. At least it's kind of final version of it. And we use AWS ECS to kind of manage this thing. The way it works, I'm not sure if everyone is familiar with Docker here, but essentially Docker is kind of like a virtual machine. It's essentially running a machine inside another machine, but it has some significant differences with how a virtual machine works. It essentially kind of reuses a lot of the system resources, and it's not a completely separate machine inside another machine. That makes it really powerful. It makes it a lot faster to kind of bring up a container or change a container or run containers in parallel or connect containers automatically with each other. So the way we use it is that we have a machine that run multiple Dockers on it, and depending on our need, we might decide to run more machines, and it's done automatically using Amazon services. It's a fairly stable system, and it's really cheap. I mean, the amount of money that we kind of save is really significant to run a very complex setup, which was previously more difficult to set up, is now much easier. For our image processing pipeline, we are using the same kind of terminology. We have Docker containers that run Landsat Util inside of it with a bunch of other services. It receives a payload, which is a request for a specific image processing job. And when it's done with the processing, it sends the result to S3, it uploads it to S3. What is really important is how scalable this is. And the way that we have designed it is just amazing in terms of how you can easily move up from one image processing to hundreds or thousands of image processing at the same time if you want. And it can easily scale in multiple dimensions, which is just amazing for us. And then depending on the type of processing that we want to do, if it's a full Landsat image, obviously we need more resources. If it's a portion of a Landsat image, we need fewer resources. But this has been incredibly stable and incredibly powerful. It has made our job significantly easier, and it's really fast. I mean, depending on the machine that we run it with very little resources, we can process a Landsat image, let's say just a full image if you want to turn it into an NDVI or if you want to turn it into a true color image. We can do this process in less than 30 seconds, which is, for us, is really fast. And it really improves the kind of workflow and pipeline that we are creating. Another example is, so we do a lot of, we are working to build a lot of different image analysis on Landsat images, but a very simple example is that, let's say if you select a part of Landsat image and you want to calculate the cloud coverage of that particular area, the pipeline that we have for this is very similar to the previous pipeline, but there are some considerable differences to how it used to be done in the past, and it makes it really fast. When you want to calculate the cloud coverage of a specific area, because Landsat images have a special band called QA band, which basically has information about the cloud coverage and snow coverage and other things on the image. All we need is that particular band to kind of calculate how much cloud you have in a particular area. That band is a very small file. It's usually 2-3 megabytes, whereas each other band is about 150 megabytes or so. So all you need is that little file to kind of calculate that cloud coverage. Because Landsat images are now on S3, in our pipeline, when we want to calculate a particular cloud coverage, all we need is to just download that specific band, that just 2 megabytes, and then do the process on it and move on to the next image. And this is incredibly fast. We can do this for every image in just a few seconds. Depending on how big the area that you want to calculate on the image. Previously, the way we had to do it was that you had to essentially go and get the whole zip file, which was less than a gigabyte of file, a very huge file. You had to spend a lot of time to unzip it. Then you only needed that 2 megabyte file. And then from that 2 megabyte file, you needed probably a few kilobytes of data to just see how much cloud you have in a particular area. Obviously, I mean, we have a use case to know how much cloud you have in a particular area, but I mean, this is just an example. I mean, we do this for other things. For example, we might use it for comparing the NDVI value of a particular field. And again, we can go through the same process. And just recently, actually, I didn't know that Jed told me yesterday. I mean, Jed told everyone in the other conference that we attended yesterday that because AWS is essentially changing the order of bits inside the image and kind of order them in a way that you can access them as tiles. And because it's over HTTP, you have this possibility that if you want to have just a portion of one image, instead of downloading the whole thing, you can just go and download that little portion and then do the rest of the process on it, which would be incredibly faster after we kind of start using this new technique. And as this image shows and as the other one, the scalability is really important for us. These are, again, are being run on EC2 instances using Docker, etc. But the fact that we have this ability to run as many of these workers completely separate from each other, independent, to just do a task. Basically, it's like starting a machine, running a bunch of process on it. I mean, running a bunch of process on the image that you want and then shutting down the machine. That's how this Docker workflow works. But it's just incredibly fast. The moment that, from the moment that you start the Docker container to the moment that the process actually starts is less than a second. And the whole shutting down the Docker and getting rid of it is also less than a second. So it's very, very fast, and it has worked incredibly well for us. Also, because Docker is a lot easier to make changes into our workflow. So all we do is that we update our image on our Docker hub, and that's it. This work that I just explained to you is part of what AstroDigital does. It's actually part of the infrastructure that we have built for AstroDigital. If you go to their website, astrodigital.com, I should have put a link there, you can actually do some experiments with their work. If you go on that imagery link on top, you can actually see a version of our Libra browser, and then you can order images. You will get an email when you order an image, etc. One point that I want to make here, which is really the kind of theme of my talk, is that all of this is really possible because this data is in the cloud, on the cloud. Not only that, but also the fact that this data is open. I mean, there are these two important factors that if you take any of them, this whole presentation that I gave you, the whole thing will collapse. It really depends on these two important elements. It's on the cloud and it's open. And I guess we have to give a huge shout out to USGS and NASA for making sure that this data is open. And then willingness of organizations such as AWS, Amazon to actually take these and make them more available to you. I mean, to just go over some of the things that I mentioned during the course of this presentation. An important element of all of our work was having the Landsat API, having the ability to search through the Landsat metadata. And that's all possible because USGS puts that CSV file, that huge CSV file of all of Landsat metadata on their website every day or every few hours. If they didn't do that, we could not have built a bunch of tools that I showed you. And then the rest of it is because AWS hosts the data, and also, with apologies, Google Storage also hosts the zip files on their zip files of Landsat data on their servers. Of course, the big difference is that those are zip files, which creates a lot of complications for our process and kind of slow it down. But from the moment that this data has been available on S3, so many new opportunities have been created that we are using them, and it's really incredible. Another technology that we use, and we really rely on it, is Docker. This is also a fairly new thing. I did not know about Docker, I guess. I mean, I have heard about it, but have not touched it a year ago. But we have rapidly started experimenting with it and learning about it, and now it has been an integral part of all of our operations. It has enabled us to essentially build very complicated production systems that are scalable with very little knowledge and experience about server administrations and DevOps and those kind of things. I mean, essentially in our team, we really do not have a full-time DevOps person. We do not have a person who is just doing server work. But we have been able to build these systems ready for production use because of the power of Docker, which allow us to have containers that can rapidly be started and shut down and be independent from each other. And it has very incredible ways of basically updating your containers and updating the base code that runs in the container, which makes it really powerful. So because I'm short of time, I'm just going to very rapidly go to my last slide. This is, I mean, obviously all of you can go and use Landsat Util if you want. If you search it Landsat Util, you will find it and enable you to, process images very, very rapidly with like no knowledge about how image processing work or how Landsat work or what the details of the sensors are. This is one image, although I mean it doesn't look as good as on my screen. But anyway, this is one of the images. I processed this image with Landsat Util. And it actually allows you to even give it like dimensions of, or actually it crops the part of image that you want to even do that part of it for you. And this is one example of the work that Landsat Util does. With that, I guess I close my presentation. If there are any questions, please let me know.
You said that for your in your Docker workflow, you're processing the QA layer just on the fly. Do you end up caching those in some sort of database so you don't have to do it again, or not? And how do you manage the payloads that are going into the Docker images? Are you using SQS or something else? I don't know. How do you do that?
Yeah, that's both of them are very good questions. So now, currently we do not cache any of those data, and I guess the reason is that, I mean, we are not yet at a level that we see a lot of specific polygons be kind of reused. So I guess every polygon that we receive is kind of unique, so there's really no purpose of caching the data at this point. But we are actually, this is one of the challenges that we're kind of trying to deal with, which is if you see that a bunch of data are being requested a lot, or if a particular area you're interested in, and you know that you always need the data of that particular area, let's say a farm field, would you try to get the data and store it somewhere, let's say in a database, rather than being on disk? And this is something that we are working on, and because we think that if you even have a faster access to data, you can do a lot more. I guess even having this thing on S3 and having a very fast HTTP access is not replaceable with like having even a faster in-memory or in-database access to some of this data. So that's another thing that we are working on. On your second question, no, we do not use Amazon SNS or those messaging services. Right now, we are actually, we haven't moved fully to ECS when it comes to our image processing. We are actually using another service that is built on top of EC2, which is called Ironworker, that kind of handles some of these things for us. But our plan is to move toward that direction. In terms of what sort of messaging service we use, I don't know. I guess it's too early for us to know that, to know the answer to that. Any other questions? Okay. Thank you.